Welcome, everyone. My name is Felipe, and I will be your host for today's ScyllaDB virtual workshop. For those of you who are not familiar with ScyllaDB yet, it is the database behind Game Changers, organizations whose success depends upon delivering engaging experiences with impressive speed. ScyllaDB was built with a close-to-the-metal design that squeezes every possible ounce of performance out of modern hardware. This translates to predictable low latency, even at high throughputs. And with such consistent innovation, the adoption of our database has grown to over 400 key players worldwide. So many of you will recognize some of the companies among the selection pictured here, such as Discord, who's using ScyllaDB to connect several users around the globe in real time. Ticketmaster, who use ScyllaDB as a backend for their ticketing platform, and Comcast Xfinity, who power all live TV recording with ScyllaDB. As it can be seen, ScyllaDB is used across many different industries and for entirely different types of use cases. More than often, your company probably has a use case that is a perfect fit for ScyllaDB, and it may be that you just don't know it yet. So, I am Felipe Mendes, and I work as a solution architect at ScyllaDB. My main role is to work closely with users during their ScyllaDB adoption journey, gather requirements, offer consultation, and ensure that ScyllaDB is the right solution for your needs. I have been working with distributed systems and databases for over 10 years, and during my career, I have always been passionate about helping our community, and I essentially love having a hard problem to solve. All right, so let's quickly go over our agenda for today. First, let's talk about some of the existing challenges that are seen when we are working at scale in order to understand why a database like ScyllaDB exists. Then let's see how ScyllaDB addresses these pain points. Next, we will discuss how to get started with ScyllaDB, where we will be showing you a demo on how to get started. And finally, we will conclude with next steps in order for you to explore and learn more about us. All right? So let's start with some modern scaling challenges. We know that organizations nowadays pretty much work in some sort of an endless cycle, some sort of an endless loop, where their goals are essentially primarily focused on growth, which can translate to bringing in more revenue, enhancing their user experiences, expanding their reach, etc. While at the same time, they want to save on money by reducing operational and infrastructure costs. While these goals can be easily explained and can be easily understood by anybody, they are very hard to achieve in practice. After all, it's natural that as your business grows, the amount of data that you need to process will scale accordingly. Your users will become more demanding, especially when there are competitors in the market that you are currently operating with. As a result, your latency requirements will become more sensitive to spikes up to a point where you will have to inevitably eventually scale your infrastructure, which will end up increasing your complexity and costs. We talk to several users and companies on a daily basis, and this slide pretty much summarizes most of the pain points that they are trying to solve when they speak to us. All right? This essentially brings us to the first poll of today. What are your existing challenges currently, and what can we do in order to help you overcome those? Maybe your existing database is too expensive, or you are having difficulty scaling. Perhaps your latency is too high. or maybe you need 3 PhDs to manage. So I can see we are already getting a lot of feedback. Thank you very much for all those answers. Let's give a few more seconds in order for people to answer. And I already know which option is essentially being the winner, but I won't leak it to you, at least not for now. And all right, thank you very much for those responses, and let's move on. So, in order to address the previous challenges that I just spoke about, we therefore need a solution tailored specifically to focus on these problems. So, the typical requirements that users and organizations have when they are engaging with us, for example, are the need to run on top of not only a highly available, but also a reliable platform, such as Discord, who runs ScyllaDB behind the scenes for their mission-critical workload. They also need a platform which is capable of consistently delivering extremely low latencies in order to deliver more engaging user experiences, such as several streaming platforms running on top of ScyllaDB in production today. All of this is needed while costs are kept under control. Therefore, it is unsurprisingly that users actually struggle when they start operating at scale. It's been a few years now when IDC said that all data generated would double every 2 years. With social networks, IoT devices, smartphones, and other devices generating large data volumes on a daily basis, we've got to a point where all this data could no longer fit under a single server, as we typically use it to do a few decades back. And that's essentially when distributed databases were born in order to address this situation. However, we get to the first problem. As your data or your business keeps scaling and scaling and growing, you may eventually end up with a very old-fashioned problem. And what most people will typically tell you is that as you scale, just add more nodes. That's what people will typically say. And a few months or years later, you will realize that you ended up with a very large footprint, preventing you from actually, well, sleeping in peace. Here, it is worth mentioning that server sprawl is a problem even if you are running in serverless solutions databases such as, for example, DynamoDB or Google Bigtable. The only difference here is that managing the actual infrastructure, managing the database is not your problem, but you will definitely pay for its management in one way or another. Here's another problem that you may have found yourself at least at some point. This slide pictures the architecture of a regular application where we have the user interacting with our actual app, and that application will receive requests from the user, and it will communicate with other services internal to your organization. And then these services will eventually end up hitting the database. So what typically happens is that if your database gets overwhelmed and overloaded with requests, then your end user will start seeing errors, slowness, and in some extreme cases, it may even cause an application outage, depending on how severe the problem gets. So what most people do in order to counter the problem that I just described is very simple. Well, we take some of the load off the database and we add a cache in front of it. And that's a brilliant idea because now you have increased your costs, you added complexity to your entire infrastructure, you have a new component that you have to deal with, and you have to change your application logic to handle both the database queries and your cache invalidation logic. And as we could see from the initial slides, we pretty much ended in the very same problem that we characterized in the beginning. So the poll that you have answered at the beginning of this workshop wasn't really a random one. In fact, we have launched the very same poll at AWS reInvent, and these are the results and from the feedback of our users. All right. So in case you are curious on how your answer actually stack to the feedback of people attending at AWS reInvent, just take a look into this slide. All right. So given all of this, let's now understand where ScyllaDB fits and how we actually solve those problems that we just characterized. So if we analyze the evolution of databases over the years, we can say that distributed databases prominently became popular starting in the year 2000. After all, that's when cloud became popular and we saw an explosion of data-driven platforms. ScyllaDB was born a decade after, when the cloud evolved to support more powerful hardware. So, in contrast to the previous slide, here we shift focus to the cloud evolution. We can see that cloud instances have dramatically evolved over the years. Not only network cards, storage, and CPUs became faster, their prices also became more competitive and more accessible to end users. And if we take a closer look into several different database types, we can easily see that they are not capable of addressing the problems we have previously discussed, which makes sense as these technologies were born in a time when these problems were either unknown or very unlikely to happen. That said, one of the things that I want you to keep in mind here is that ScyllaDB is not going to exactly replace all of these database pictures pictured here on this slide, but we are going to essentially do a very quick walkthrough over the limitations of each solution. Okay? That said, traditional relational databases are great for processing structured data. You can do easily cross-table joins and you can run complex ad hoc types of queries. But the problem here is that they don't scale and the performance is very suboptimal. Small workloads will typically run perfectly fine on top of relational databases, but as soon as you have to scale beyond what a single server can, you will need to introduce sharding, you will need to spread your data to work in a distributed fashion, and as a result, it will become a burden to manage, and you will lose a lot of performance because the traditional relational databases were not simply made to work in that way. All right. We then get to databases like MongoDB. And here, I will be honest with you people and just say that I love MongoDB. It's so easy to learn and it's so easy to get started. MongoDB is very flexible because it basically doesn't require any structure at all. So whatever you tell MongoDB to do, it will do without complaining to you. So the only problem is that with all this flexibility of MongoDB comes with a cost. So MongoDB is typically also a great fit for small workloads which don't have strict latency requirements and where throughput is low. But by the time you need to introduce more replica sets and sharding to your MongoDB deployment, most people eventually will realize that choosing database like Mongo was an unfortunate mistake. Okay? We then get to databases like Redis and Memcached and other in-memory types of databases, which are often used as a caching layer. They are also very simple to use, but unlike MongoDB, they are also very fast. The problem is that they do not persist your data, and to be quite honest, No company can afford running all their data set on top of memory, as this is not an economically viable option. Um, Not to mention the fact that if one of your cache replicas goes down, you pretty much lose all of your data, which means that you need to build your own backup and restore plans when that happens. All right? And lastly, we finally get to databases like Cassandra and DynamoDB, which are a leaderless type of NoSQL persistent database that can easily be scaled to work across multiple regions, multiple zones. They have great high availability, but they still suffer from the performance and node sprawl problems that we have discussed earlier. All right? So, ScyllaDB was born to address these challenges altogether. In particular, it was made to make use of modern hardware efficiently, requiring a smaller node footprint, consistently delivering low latencies, even under peak, and no less important, be simple to use and very easy for you to migrate to. As a result, ScyllaDB is the database for data-intensive applications. If you have a high throughput workload with very aggressive latency requirements, then you are already a good fit for us. ScyllaDB will scale both out and up as your workload requires. Unlike other databases, however, users typically see a large reduction in their deployment size when they decide to stick with ScyllaDB. Comcast, for example, reduced it from over 900 Cassandra nodes to less than 100 ScyllaDB nodes. At the same time, while we reduce our node count, we also deliver extremely low latencies. The same Comcast I just spoke about decreased their P99s by 95% of what they were seeing previously in their Apache Cassandra deployments. ScyllaDB is also extremely simple to administer. We often hear from many users that we managed to actually get their sleep nights back. So some people even dare to call us a boring database, a sign that we require very little babysitting. As a result of all of this, we require less infrastructure and administration, which has a direct impact on your cost savings. Now, you may be wondering which kind of witchery we have done in order to get to these benefits. And guys, honestly, I could probably talk here for around 1 hour or so around ScyllaDB shared per core architecture, how we are built on top of C++, or shared notching programming models, or specialized cache. I could talk about how we implement our I/O scheduling and we isolate resource from each other, how we have NUMA awareness, one aspect that very little databases in the market have, etc. But instead of doing all of this, what I want you to understand here is that we are backed up by a team of not only distributed system engineers, but also kernel hackers. In simple terms, what I want you to understand is that we simply decided to use our knowledge to build high performance and real-time operating systems, but instead, we're building a database. That's why ScyllaDB has a unique, close to the metal architecture and linearly scales as your hardware capabilities grow, unlike other databases, which simply have been created in another era and follow suboptimal programming paradigms. Okay? However, if you'd like to know more about why the ScyllaDB architecture is unique, we welcome you to read more about in our website following the link that has just been posted into the chat. All right? Then, how easy it is to get started with ScyllaDB? It's pretty much easy. We are fully compatible with both the Cassandra query language and the DynamoDB protocols. That means that not only you can switch your application without a single line of code change, but all the tooling that you are already used to, such as if you are using Apache Spark or Kafka, and your favorite language stack will similarly work out of the box without you having to do major changes to your actual application. All right? And if you still don't believe me and would like to know more on how we stack up against other databases, be sure to check out our benchmarks. Okay? In particular, one of the things that we are very proud of is that every single benchmark that we have, we essentially provide all the tooling, all the code that we have run for you to reproduce the results by yourself. And in this slide, particularly, you can see how we stack against DynamoDB, how we stack against Apache Cassandra, and how we stack against Google Bigtable. Okay? This essentially brings us to our second poll. And please let us know which databases are you currently working with. Maybe you are already running on top of a distributed database, or maybe you are running on top of a relational database. Perhaps you are running a cache. And once again, a lot of feedback. So thank you very much for all those answers. And let's give people a few more seconds, which I will essentially take a glass of Coke. Nice. All right. Thank you very much for all those answers, guys. And let's keep moving. So now that we have learned what ScyllaDB is, let's cover how we actually can get started with it. Oops, let's switch the slide. And all right, so ScyllaDB can be deployed either in the cloud, on-prem, or you may use ScyllaDB Cloud, our fully managed solution. Within ScyllaDB Cloud, you may start a free trial and quickly get up to speed, enjoying all the benefits we have discussed thus far. And see, Monster, don't drop, keep here, done. So in addition to the actual ScyllaDB server, we also provide for free the ScyllaDB monitoring stack, which is extremely powerful and allows you to quickly gain insights not only on how your database is performing, but also your application. The ScyllaDB monitoring stack makes it extremely easy for you to set up custom alerts according to your business requirement and integrate these with your favorite notification channels that you may already be using in your organization. All right. And we also have ScyllaDB Manager, which allows you to easily schedule, run, and track maintenance activities such as backups, repairs, and restores with a single command line. And for actually doing backups and repairs and restores, it integrates with all major cloud APIs for object storage. All that said, and as we promised in the beginning of this presentation, let's now see ScyllaDB in action. All the material that we are going to use here is going to be shared to you in the chat, so you can later on follow along and run it by yourself. But for now, don't just save the link and stick with me. Let's see what this demo actually does. So we are going to break down the demo in two parts. In this first part, we are going to demonstrate two ScyllaDB clusters running. On the first cluster, we will be ingesting data, then using the ScyllaDB CDC Go driver, we will stream that data in real time to the second one, okay? So the purpose of this demo is to demonstrate ScyllaDB latencies under load, along with the ScyllaDB monitoring stack, which we have previously mentioned. The provided material contains a Docker Compose file, which, when you get started, should take care of provisioning the entire infrastructure you need in order to get going. All right, so let me switch to my terminal. And in order to save us time, I have already started the containers. And we can see over here the stress container essentially ingesting data nonstop to one of our clusters. And we also have the replicator container over here, which is essentially replicating the data from one cluster to another. It's essentially taking care of reading the ingested data and streaming it to the other cluster. So let's switch to the monitoring stack and see how things are looking over here. So this is essentially the overview page of the ScyllaDB monitoring. And as you can see, it's currently running 2 nodes. And essentially, because we are running this in a single, everything is running in a single server, we are running 1 node for each cluster. Typically, in a production environment, you will want more nodes, but for demonstration purposes, this suffices. And since you are expected later on to run this on your own laptop, and since ScyllaDB is very research intensive, it makes sense for us to reduce the actual requirements. What else? So it's running 2 nodes, and each one is running in a separate cluster. As you can see, if we account for both nodes operations, both clusters operations, we are doing 25,000 operations per second. What really stands out here is the P99 latency. We can see that the writes are pretty much taking less than 1 millisecond, and the reads are around 5 milliseconds on the P99. If we look at the overall cluster load, we can see that the cluster is not even close to being heavily loaded. So it still has spare resources to scale even further. But do you know what's more impressive about those numbers? It's really the fact that, as I said, all this infrastructure is running inside the Docker and under a single machine, in such a way that it becomes fairly easy for us to realize how much more this could scale when run under a real production environment. So, in case you are wondering for how long these latencies have been actually being recorded, so this workload has been running for over an hour now, and I can probably try, let's see if we have metrics for 2 hours. Now minus 90 minutes, let's see. Yep. And you can see that pretty much the P99 latencies remained stable during the entire run of this test. And even though the read P99 has spiked, it's still below 10 milliseconds. So as you can see, ScyllaDB is very stable, it's predictable, and the latencies are always under control, even when your workload is running for a very long period of time. So in case you are wondering, oh, this is just a 30-minute demo, they gather the results, and then after the results are going to be skewed. No, you can get actually those numbers if you run this demo for hours, just like you are seeing here. What else? So the monitoring also comes with several other dashboards and panels which you can use to gain further insights into how your cluster is performing. So for example, over here, we are in the overview page. And if I switch to the ScyllaSQL dashboard, which is one that I particularly like. We can quickly see what is the ratio of writes, in this case, updates and reads. So here we can see that one of the clusters is writing more data than the other, which makes sense because we are essentially streaming data via CDC from one cluster to the other. And what our CDC job does, it's essentially is going to break all the ingestions that it collected from the first cluster and then string it in smaller chunks to the other one, hence why it has more operations per second. And we can see also the reads over here. We can see that our replicator job, the job which is responsible for doing replication, is actually doing only 25 reads per second, and it's using a ScyllaDB exclusive extension, which we call bypass cache. So what bypass cache does is essentially it will, when it reads from ScyllaDB, it's going to tell the database that it should not read data from memory, from the cache. Instead, the database should always go to the disk in order to retrieve the data. So in case you guys were wondering, why is the read P99 latency that we saw earlier that high, but yet it was still below 10 milliseconds? That's the reason, because our reads were being served by the disk and not from the cache. And I essentially have to make a pause here, guys, and ask you, how many databases do you know can actually serve data from disk with the latencies as low as we have seen in the read P99 before? All right. So what else do we have interesting in this ScyllaSQL dashboard? If we scroll down, we will eventually get to this optimization section. And here we can gain insights over how our application is performing, whether we are following the best practices, such as whether we are not making use of prepare statements, whether we are running unpaged queries, etc., and so forth. So the ScyllaDB monitoring stack will also help you during your actual application development steps. All right. As a summary, it's a very powerful tool that you will always want to deploy along with your ScyllaDB deployment. And you have no reason not to be quite honest, because after all, as I said, the ScyllaDB monitoring stack is open source and free for you to use. All right. So that was the first part of the demo. And then we get to part 2. And this one is actually a more interactive one. So what we are going to do is to play the tic-tac-toe game. And the reason for this demo is to actually demonstrate how the ScyllaDB DynamoDB API is actually compatible with AWS Dynamo. The tic-tac-toe program that we are going to see was originally written by Amazon themselves in order for them to demonstrate how users could get started and learn about the DynamoDB concept. And what's cool about that demo is that it demonstrates several DynamoDB features, such as creating table, update statements, transactions, etc., and so forth. And it works out of the box along with ScyllaDB. So let's go to our terminal. And once again, to save us time, I have already started the actual application, which is written in Python. So it should be very simple for you to get started if you have never seen it. And by the way, the GitHub instructions the GitHub page contains instructions on how you can start the tic-tac-toe program. And I have already started it. So let's, after you start the program, you will essentially point your browser to port 8080, and from there, all you have to do is to actually log in. Okay, so for example, I will call myself user1, and I will log in the browser above here, and I will create a game. And then the program will essentially tell me to choose an opponent. And from here, I will say that I want to challenge user 2. And let's create a game. And then we are essentially going to be redirected to the game page. And we can see that the game status is pending because user 2 hasn't yet logged in to the game. So if we try to play without user 2, we are going to get this message, which I don't know if you can read it, but it essentially says that the game hasn't started yet. All right. So now that we have a game started, let's log in as user 2 in the browser window below. And as, oops, I logged in as user 1, I'm sorry. So user 2. Yeah, and as we log in as user 2, we are then essentially going to get a pending invitation from user 1 saying that he wants to play a game with us, and we can accept or reject. To make things simple, let's simply accept it. And then we get to the actual playing page with both users. So here, let's play as user 2, and user 2 is going to make this move, and then user 1 makes its move, then user 2 makes its move, and user 1 makes a mistake, and user 2 goes and wins the game. Okay? And that's essentially it. I mean, it makes use of several DynamoDB calls under the hood. In fact, if we go back to our terminal, we can see here that the item format is pretty much the same as you would actually use when you are coding an application for DynamoDB. All right? So that's essentially the actual demo. That's what we had to show. And if you would like to know more about ScyllaDB, or if you want to learn more on how we can help, feel free to book a one-on-one technical session with me personally. Or I don't know, maybe you are feeling shy. So my email is on the screen, and you can reach out whenever you want to ask whatever questions you may have. I will be more than glad to get in touch with you. All right. So we hope you found this workshop informative. You have seen how easy and simple it is to spin up a ScyllaDB cluster and how it scales smoothly. When you actually decide to move your work to production, remember to properly gather your application and business requirements, and then select the right infrastructure for your needs. In that sense, I highly recommend you to watch one of our sizing videos in order for you to learn more on some of the considerations that you need to have from both resiliency, scalability, and high availability perspective, so that when you are actually moving your work from development to production, you can actually succeed with your deployment. All right. And this essentially brings us to the last poll of today. And here we essentially would like to hear your feedback so we can tune down this workshop to match your needs. In particular, if you feel like you would like to see something which is not being covered here, if you feel like it's not being technical enough, please let us know in the chat what you would like to see so we can adjust the future versions of this workshop to ensure we are covering what you are actually expecting. So drop your feedback into the chat and I will look into it. All right. Let's talk now about next steps. So if you'd like to know more about ScyllaDB, be sure to check out on these resources. First, spin up a cluster for free in ScyllaDB Cloud. You simply have to go to scalladb.com/cloud. We also provide free NoSQL and ScyllaDB specific training in ScyllaDB University. So if you are getting started with ScyllaDB, if you don't know what NoSQL is, simply go to scalladb.com/university. And lastly, visit our resource center to learn how users are using ScyllaDB, what are the use cases, their strategies, how ScyllaDB helped them, learn more about best practices, and of course, stay tuned with our latest news. Guys, thanks for joining us today. Be sure to follow us through our social channels. Stay tuned and see you soon, guys. Bye.